In comparison to old technology aircraft, the flight deck on the A320 is designed to be a comfortable, uncluttered environment in which to work. By using modern electronic display units, the presentation of information to the pilots has been improved. The Electronic Instrument System, EIS, consists of 6 identical full-color cathode ray tube display units. The EIS is divided into 2 subsystems. The Electronic Flight Instrument System, EFIS, for which each pilot has 2 displays. The Electronic Centralized Aircraft Monitoring System, ecam, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the EFIS system first. Flight parameters are displayed on primary flight displays, PFD, while navigation data is displayed on navigation displays, ND. Outboard of the PFD, there are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off. A switch is provided to allow the information on the PFD and ND displays to be transferred. The use of this switch will be explained in the EIS reconfiguration module. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System, ecam. At this stage, we will simply introduce the ecam displays and associated controls. In later modules, the ecam system will be studied in detail. The upper ecam display is known as the Engine Warning Display, EWD. The lower ecam display is known as the System Display, SD. It is on this screen that various aircraft system parameters can be viewed by the pilots. As an example, we will cycle through the system pages for you. The presentation of system information is based on a need-to-know philosophy. This means that only the system information relevant to the particular phase of flight is presented to the pilots. You will see this demonstrated in the normal and abnormal operation modules. Another philosophy that is used on the flight deck is the lights out configuration. What this means is that when the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. As an example, just before takeoff, if you look up at the overhead panel, there should be no white lights illuminated on any of the switches. Let's look at some switches and show the different possibilities. For the majority of the switches on the overhead panel, the push-button switch logic is normal operation configuration, no light showing, the lights out philosophy. Abnormal condition, amber fault light. This assists identification of the switch associated with an abnormal condition. White light. If normally the system should be operating and is deactivated, a white off light is illuminated. If normally the system should not be operating and is activated, a white on light is illuminated. There are some switches on the overhead panel which are used on a temporary basis or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light, for example, anti-ice. Applicable system status, green light, for example, APU available. You will see this philosophy demonstrated throughout the course. Below the ecam displays on the center pedestal is the ecam control panel. The two controls on the left-hand side are to adjust the brightness of the two ecam screens or to turn them off. We will look at the rest of the controls on this panel in more detail later. Just below the ecam screens on the pedestal is a switching panel for use in abnormal situations to restore data to the EFIS and ecam displays. You will use this panel in the EIS reconfiguration module. In front of each pilot there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note: the loudspeakers can also be used to listen to ATC and the intercom. Now let's go back to the EFIS system. For the EFIS displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management and Guidance System, FMGS, is fed directly to three display management computers, DMC. The three identical DMCs process the data and generate the images to be displayed. In normal operation, DMC1 supplies EFIS information to the captain's PFD and ND, DMC2 supplies the first officer's PFD and ND, DMC3 is available as a backup. You will see the use of DMC3 in the abnormal operation module. Now let's look at the other EIS subsystem, ecam, and how the ecam displays get their data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated on the flight deck. Data for certain parameters, for example fuel quantity and primary engine indications, is routed directly from the system sensors to the three DMCs. Note that there are separate channels within each DMC for ecam and EFIS. For the majority of the systems, the sensors supply data to two System Data Acquisition Concentrators, SDAC. The SDACs acquire system data, process it, and send some of it as system page data to the three DMCs. Normally, DMC1 supplies the engine warning display. DMC2 supplies the system display. DMC3 is available as a backup. Two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings, the SDACs to generate amber cautions. The FWCs then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts and synthetic voice messages. All the components shown can be collectively called the ecam system. We will study the use of the ecam system in a separate module. In addition to EFIS and ecam, time measurement devices are provided. The master time reference for all aircraft systems is provided by a clock, located on the right lower side of the main panel. In this example, the time is 13:28. The time is also displayed at the bottom of the system display. Adjustment of the time is achieved by using the Universal Time Coordinated UTC selector and the Set knob. You will have the opportunity to do this in the simulator. The Set knob can also be pressed to display date information in the order month, then day. In this example, the date is July the 4th. There are chronograph and elapsed time ET facilities on the clock. These functions will be covered later. In this module, we have introduced you to the electronic instrument system, with its two subsections, EFIS and ecam, and the clock. In the next modules, we will concentrate mainly on the ecam system, and then, later in the course, return to look at the EFIS displays in greater detail. The ecam system keeps a watchful eye on all of the aircraft systems, monitoring them for any abnormal states. If something abnormal is detected, ecam will alert the pilots and provide an electronic procedure to help handle the abnormality. The two ecam displays, the engine warning display and the system display, provide normal and abnormal system information to the pilots. Color coding is used on the ecam screens for clarity and to aid identification of abnormal parameters. The main colors used are white, blue, green, amber, red. During the course, you will become familiar with the use of this color coding. Let's start with the last three, green, amber and red, which are the most important. Green color coding is used to indicate a normal condition. Notice that on the engine warning display and the system display shown, all indications are normal. But amber color coding is reserved for abnormal indications that require crew awareness, but not immediate crew action. Notice on the engine warning display the amber failure message, and on the system display the amber indications. Red color coding is reserved for serious parameter exceedance and warnings that require immediate crew action. Notice the red warning message on the engine warning display. Let's now look at the two ecam displays in a little more detail. The engine warning display is divided into two main parts, the upper area and the lower area. The upper area is used for the main engine parameters, fuel on board, fob, and slat flap position indications. They will be discussed in the appropriate system modules. Under normal conditions, the lower part of the engine warning display is used to display memos. In the example shown, the memos indicate that the seat belt and no smoking signs are switched on, and that the APU is available for use. If failures occur, warning caution messages are displayed in place of the memos. In the example shown, there is an amber caution message with a series of blue action items. These action items are your electronic procedure to follow in order to respond to the particular abnormal situation. The system display is used to display particular system information. In the example shown, the cruise page is displayed. This is the page normally seen for the majority of the time that the aircraft is airborne. Information that is useful during flight from several systems is displayed. The individual indications will be covered in the appropriate system modules. The system display can also be used to display synoptic diagrams of the aircraft systems. In the example shown, the hydraulic system page has been called. You will see later how these system pages are called either manually or automatically. An aircraft status page may be displayed on the system display to check the state of the aircraft. A normal message is displayed to indicate that the aircraft state is normal and that there are no inoperative systems. Let's see what the status page looks like when things are not normal, for example, following a system failure. The information displayed on the status page will vary depending on the failure, but, as an example, can include limitations, approach procedures including actions and corrections, information, inoperative systems. The area at the bottom of any system display contains permanent data: total air temperature, TAT, static air temperature, SAT, time, gross weight, GW. Under normal conditions, the ecam system provides the pilots with the information that they need to know for the particular phase of flight, no more, no less. As an example, during approach, when the landing gear is extended, the ecam wheel system page is automatically displayed. The ecam system divides the various stages of a flight into phases, from initial electrical power up until after engine shutdown. The ecam system will avoid alerting the pilots unnecessarily during the critical flight phases of takeoff and landing. The warnings and cautions that can be delayed until a less critical phase of flight will be inhibited. We will now look at the different ways that the ecam system advises you when things are not going exactly right. We will start with a minor advice indication and work up to a major fault, concentrating on the two ecam screens. If a system parameter, for example an engine vibration level, approaches a limit, the ecam system will advise you of this by displaying the relevant system page on the system display. The affected parameter will pulse. Notice that at this stage the parameter is still shown in green, since it is still within normal limits. This is known as an ecam advisory. Now let's look at what happens when ecam detects a minor system failure. When a failure occurs, leading to a loss of redundancy or loss of a system that does not affect the safety of the flight, for example, DFDR fault, the ecam system will inform you by displaying an amber caution message on the engine warning display. This type of failure is classified Level 1. At the same time, the two clear keys on the ecam control panel, ECP, will illuminate. The first action is to ensure that the aircraft is on a safe flight path. This fault only requires crew awareness, so if required, the handling of the fault can be delayed. Normally, the pilot non-flying carries out the ecam procedure, while the pilot flying is responsible for the aircraft flight path. For this exercise, you are the pilot non-flying. Read the title of the failure. In this case, Recorder DFDR fault. In this case, there are no actions required, so after confirmation from the pilot flying, the caution message can be cleared by pressing one of the clear keys on the ECP. Press a clear key. As a result of pressing either clear key, the caution message has been cleared from the engine warning display, and the status page is displayed automatically. In this example, you can see that the inoperative system is the DFDR. On the ECP, the status key is illuminated along with the two clear keys. When safe to do so, the status page is reviewed by both pilots. After confirmation from the pilot flying, the status page is cleared by pressing either of the status keys or one of the clear keys. Clear the status page. Notice that on the engine warning display there is a boxed status caption to tell you that there is information on the status page. On the ECP, there are no lights. The ecam actions for the DFDR fault are complete. We will now look at what happens when a slightly more serious fault is detected by ecam. The fault that we will use is an overheat of the blue hydraulic system reservoir. We will concentrate on the use of the ecam system, how it alerts you, and how it helps you to deal with the fault. The hydraulic indications themselves will be covered in the appropriate modules. Click on the forward arrow to initiate the failure. When the fault occurs, the ecam system alerts the crew orally and visually. You will hear a single chime and see the master caution lights. To cancel the master caution lights and reset the alerting system, one of the master caution push buttons must be pressed. Extinguish the master caution light. The master caution lights are extinguished and the alerting system is reset. But the first priority is always to ensure the safe flight path of the aircraft before dealing with the fault. The master caution means that the abnormal situation needs crew awareness, but not immediate action. This failure, which hasn't any direct consequence on flight safety, is classified Level 2. The indications are a failure message on the engine warning display, the system synoptic associated with the fault is automatically displayed on the system display, the clear keys on the ECP light up. Let's study the details on the engine warning display first. The system title is underlined, in this case hydraulics, and the fault is shown alongside, blue reservoir overheat. Notice that abbreviations are used. Notice the amber overheat message on the system display. This abnormal indication is displayed where the failure has occurred on the synoptic system. The pilot flying will ask you to perform the ecam actions. In this example, there is a blue action line on the engine warning display telling you to switch off the blue electrical pump. Now let's check the overhead panel. On the overhead panel, an amber fault light has illuminated on the hydraulic control panel. The fault light on the hydraulic panel helps you to locate the switch to be operated. We will carry out the action for you. When the pump is switched off, the action line is removed. The blue hydraulic system depressurizes, as shown on the hydraulic page by the amber indications. The ecam system detects the drop in pressure and generates a further alert. You hear the chime and see the master caution lights. Extinguish the master caution light. There is now a new abnormal message on the engine warning display. Blue system low pressure. The message is boxed to indicate that the loss of the blue hydraulic system is classed as a primary failure that will affect other systems. The systems affected are shown on the right of the engine warning display as starred items called secondary failures. In this example, the primary failure of the blue hydraulic system has caused a secondary failure of flight controls. After review and confirmation from the pilot flying, the hydraulic failure message on the engine warning display can be cleared. Clear the hydraulics message. Notice that normal memos have returned on the left side of the engine warning display. The ecam flight control system page is displayed on the system display, which corresponds to the secondary failure item on the engine warning display. On the ecam flight control page, notice that the controls affected by the loss of the blue hydraulic system have amber indications. These indications will be discussed in the hydraulic and flight control modules. After review and confirmation from the pilot flying, the flight control secondary failure message can be cleared. Clear the flight control page. Notice that the secondary failure indication on the engine warning display has been removed. The status page is now displayed containing several pieces of information. The first area gives procedures to be applied for landing and other information. The second area gives information about inoperative systems following the blue hydraulic failure. You will study the procedures in the appropriate system lessons. The status page is reviewed by both pilots. After confirmation from the pilot flying, the status page can be cleared. Clear the status page. No, press the status key or either clear key. The ecam actions for a blue hydraulic reservoir overheat are complete. Notice that the status reminder is displayed at the bottom of the engine warning display, reminding you that there is information on the status page. This is important when approach procedures have to be applied. If it contains information, the ecam system automatically recalls the status page during the approach phase when the slats are extended. This is done if there are any items affecting the approach and landing. You can see that in the example shown, there is a landing distance procedure to be applied. You will see how these approach procedures are applied later in the training. Clear the status page. The status page is cleared and the cruise page is displayed. So far, we have looked at how the ecam system advises you of minor failures. We will now look at what happens when there is a serious failure that requires immediate action. To demonstrate this, we will use an engine fire. As before, we will not concentrate on the system failure, but on ecam indications and procedures. This kind of failure is classified Level 3. Be ready to cancel the warning by pressing a master warning push-button switch. Click on the forward arrow to initiate the failure. When the fault occurs, the ecam system alerts the crew orally and visually. You hear a continuous, repetitive chime and see the master warning lights flashing. Press one of the master warning push buttons to cancel the master warning lights, stop the chimes, reset the alerting system. On the engine warning display, the red message Engine 1 Fire and the associated procedure are displayed. The red push button on the fire control panel and the red indication on the engine panel provide confirmation and identification of the affected engine. The engine page has automatically been called on the system display, and in this example the nacelle temperature is pulsing. Notice that there is a red Land ASAP message on the engine warning display. This means that the fault detected is serious enough to require a landing as soon as possible. The pilot flying maintains control of the aircraft and asks you, as pilot non-flying, to start the procedure. We will do the ecam actions for you, starting with setting thrust lever 1 to idle. This action would be done by the pilot flying. CF task sharing. Note, when the first officer or captain has to move one thrust lever, the SOP recommends cross-confirmation of both pilots. The second action to be performed by the pilot non-flying, after confirmation by the pilot flying, is to switch engine 1 off, as written on the ecam procedure. We will do it for you. After switching engine 1 off, the engine 1 shutdown procedure is shown on the engine warning display. Notice that the amber caution procedure has appeared below the red one. This happens because you have to finish the engine fire procedure before carrying out the actions for engine 1 shutdown. The ecam system has automatically allocated priority to the warning. As a result of switching off the engine, there are now secondary failures. The next ecam action to be performed by the pilot non-flying, after confirmation by the pilot flying, is to push the engine 1 fire push button. We will do this for you. Notice that there is a white line in the abnormal procedure. In this example, there is a delay in discharging the agent to let the engine spool down. We have paused the countdown at 10 seconds. To continue the countdown, click on the forward arrow. When the countdown is complete, a blue action line appears, telling you to discharge the first fire bottle. We will do this for you. The next action line is for the pilot flying to notify ATC, Air Traffic Control. Since the ecam system cannot tell when you are talking, there is no feedback, so this line will not disappear. Notice that we still have a red fire indication. which means that the fire is not extinguished. Another condition line has appeared, and a second countdown automatically starts. This one is 30 seconds long. We have paused the countdown. To continue the countdown, click on the forward arrow. Agent 1 managed to extinguish the fire. The countdown for Agent 2 stopped immediately. Notice that the engine fire procedure on the ecam disappeared. This means the fire is out. The local warnings on the fire control panel and the engine master panel are no longer illuminated, confirming that the fire is out. Land ASAP has changed from red to amber, which means that ecam has determined that the fault is less critical, but still requires a landing as soon as possible. The remaining steps are similar to those seen for an ecam caution, so we will stop here. You have seen that the ecam system has provided a smart and interactive procedure to help you deal with a major problem. So far, the messages and procedures displayed on the engine warning display have not been more than 7 lines, so we have had room to display them all. Let's look at how ecam copes with a long procedure. In this example of the indications for an engine fire on the ground, there is an overflow arrow to indicate that there is more information to be seen. For training purposes, we have shown the rest of the procedure below the engine warning display. We will complete the ecam actions, and you will see the associated line of the procedure disappear. As actions are completed, the rest of the information will be displayed, and the overflow arrow will be removed. On the status page, an overflow arrow also indicates that there is further information to be seen on a second page. By pressing a clear key, the next page can be displayed. Press a clear key. The second page of status information is displayed. Notice that the list of inoperative systems has not changed, and that there is still an overflow arrow. Press a clear key. The last page of inoperative systems is displayed, and the overflow arrow is removed. If you want to display the first status page again, the status key can be pressed. Press the status key. We're now back at the first status page again. You will have the opportunity to practice moving between status pages in the simulator, so we will stop here. To summarize, initially you see all the information on the left side of the status page, and then all the inoperative systems on the right. To complete this module, let's briefly look at ecam priority. For this demonstration, we will only use the bottom part of the engine warning display, and we assume the engine 1 fire procedure is complete. You are partly through the engine 1 fire procedure when ecam detects another failure. The low priority recorder DFDR fault has appeared below the higher priority engine 1 fire and engine 1 shutdown procedures. Unfortunately, it is one of those days and another failure occurs. The autopilot off warning has appeared above the engine 1 fire procedure. ecam has automatically assigned priority to the autopilot off message because the first priority is always to fly the aircraft. The low priority recorder DFDR fault is now off the screen. You are advised that the fault is there by the unstarred recorder text in the right-hand column of the engine warning display and the green overflow arrow. We will clear the Auto Flight Autopilot Off warning for you. The recorder DFDR fault message is back at the bottom of the engine warning display, and the recorder text has been removed from the right-hand column. In this module, we have discussed the ecam system. You have seen the various failure levels and how the ecam system alerts, indicates, and helps you deal with a failure. Throughout the ground school course, and during your simulator sessions, you will have the opportunity to practice ecam procedures. When you initially enter the cockpit, all the EIS displays are normally off. The displays require AC electrical power to operate, so unless either the APU or a ground electrical supply are available, the displays will not operate. We will connect a ground electrical supply for you. The ground electrical supply is connected and powering the aircraft. Normally, the ecam screens are switched on, first the upper, then the lower. For training purposes, let's switch them on in reverse order to see what happens. Switch on the lower ecam display. Notice that engine warning display information is displayed on the lower ecam screen. This occurs because it has priority. Therefore, if there is only one ecam screen available, the engine warning display information will be displayed. Now switch on the upper ecam display to see what happens. Switch on the upper ecam display. Notice that the engine warning display information moves to its normal position on the upper ecam screen, and the door oxygen system page is displayed on the lower ecam screen. The door oxygen page is what the ecam system will automatically display because you are on the ground with the doors open. The memo area of the engine warning display has a message telling you that refueling is taking place. We will now start the APU. Click on the APU picture. Notice that the APU system page is automatically displayed by the ecam system. There is no light on the ecam control panel, ECP, APU key, because the APU page has been automatically called as part of a normal sequence. The APU is now running. Shortly after the APU start, the ecam door oxygen page is automatically recalled. The next action is to press the recall key on the ECP for at least 3 seconds. Pressing this key recalls any warnings or cautions that have been cleared since the last power-up. Press the recall key. Since we are performing a cold start of the aircraft, a normal memo will be seen on the engine warning display, because there is nothing to recall. If we were on a turnaround, the display would recall any warnings or cautions that had occurred on the previous flight. In this example, a cancelled caution concerning the Digital Flight Data Recorder, DFDR, has been recalled. You will see how a caution is cancelled in the abnormal operation module. During the pre-flight, one of the things we do is to check fluid levels: engine oil, hydraulic fluid, fuel. The required system pages are manually called by pressing the associated key on the ECP. Let's call the ecam hydraulic system page. Press the hydraulic system key on the ECP. The ecam hydraulic system page is displayed. Notice that there is a light on the hydraulic key on the ECP to indicate that it was manually selected. You will do the fluid level check in the hydraulic module. So let's see how to return to the ecam door oxygen page. To deselect a manually selected ecam page, press the ECP lighted key. Press the hydraulic key on the ECP. The ecam door oxygen page is displayed, and there are no lights on the ECP. Remember the lights out philosophy. The switching panel is checked to confirm that all the switches are in their normal position. The passengers have boarded. The doors have been closed, and the aircraft is ready for pushback. Notice that on the door oxygen page there are green indications on all the doors, which means that you are in a go state. When the ground personnel attach a tow bar to the aircraft, they disconnect part of the nose wheel steering system. The ecam system will detect this and provide a green memo indication: nose wheel steering disconnected. Let's start the engines. Click on the engines to start them. The ecam system will automatically display the ecam engine page during engine start. Notice that as soon as the first engine is running, the nose wheel steering disconnected memo changes to amber. This happens because ecam has detected that you are capable of taxiing, but you have the steering disconnected. The pushback is complete. Both engines are running, and the parking brake has been set on. Notice that when the ground personnel reconnects the nose wheel steering, the amber memo disappears. The ecam wheel page is automatically called, so that during taxi, the brake temperatures can be monitored. Part of the after-start checks involves arming the ground spoilers and setting the flaps. We will arm the spoilers for you. You can select the flaps. Click on the flap lever. We have armed the ground spoilers for you. A memo appears on the engine warning display showing that the ground spoilers have been armed, and the flap indication changes to show the flap setting. Another part of the after-start checks involves checking the status page. In the example shown, there is no status reminder at the bottom of the engine warning display. That means the status page is empty. The APU is no longer required, so we have switched it off for you. All that remains in the right-hand memo area is the parking brake message. The door oxygen page should be checked to confirm that all slides are armed before commencing the taxi. Call the ecam door oxygen page. No, call the ecam door oxygen page. On the ecam door oxygen page, observe that there are no amber indications and that there are 6 white slide indications. You will see more about the door oxygen page in the Doors modules. Deselect the door oxygen page. The ecam door oxygen page is replaced by the wheel page. The aircraft is now ready to taxi. The brakes are released, which clears the park brake memo, and the clock elapsed time is set to run. Select Run on the clock elapsed time. The elapsed time is now running and the aircraft is taxiing out. The flight controls are checked during the taxi out. The ecam system automatically calls the ecam flight control page as soon as any of the flight controls are moved on the ground. Approximately 2 minutes after the second engine has been started, a takeoff TO memo appears on the engine warning display. The takeoff memo lists a series of actions required by the crew for the aircraft to be ready for takeoff. If you look at the list, you can see that there are blue action items remaining, specifically setting the auto brake to max and a takeoff configuration test. We will set the auto brakes to max for you. The blue action comment changed to green and moved. Just before completing the before takeoff checklist, the takeoff configuration test is carried out. This is done by pressing the takeoff configuration key on the ECP. Select the takeoff configuration key. By selecting the takeoff configuration key, the ecam system simulates the application of takeoff power. If the aircraft is not in a takeoff configuration, for example flaps not in the correct configuration, then an ecam warning or caution will be triggered. Provided ecam detects that the aircraft is in a normal configuration, then the takeoff configuration memo changes to normal. Observe that there are no blue action lines on the engine warning display. We are now taking off, about to apply takeoff power. If required, the chronometer may be started. Start the chronometer. Observe that the chronometer has started. When the engines are set to takeoff thrust, the ecam engine page is automatically called. On the engine warning display, notice that the takeoff memo is replaced by normal memos. A magenta takeoff inhibit message has appeared. The takeoff inhibit message advises you that some warnings and cautions have been inhibited during the takeoff phase. The aircraft is now airborne. After passing 1500 feet above aerodrome level, or 2 minutes after liftoff, the takeoff inhibit ceases and the memo is removed. At the acceleration altitude, the climb phase is activated The aircraft accelerates and the flaps are then retracted, step by step, when reaching sufficient speed. Click on the flap lever. When the flaps are fully retracted, the ecam engine page is automatically replaced by the cruise page. The aircraft is now established in cruise. Periodically, a routine review of the system pages is carried out. Call the ecam engine page. Notice that while the engine page is displayed, the corresponding light on ECP engine key is illuminated. You will study the indications of the system pages in the appropriate modules, so let's continue with the review. Call the ecam bleed page. Let's continue the review. Call the ecam pressurization page. To continue the review, we will do the action for you. First of all, we will call the electrical page. Now the hydraulic page. Now the fuel page. Now the APU page. Notice that there are amber indications on the APU page. Because the APU is shut down, these are acceptable for this stage of flight. We will now call the ecam conditioning page. The ecam door oxygen page. The ecam wheel page. The ecam flight control page. After reviewing the flight control page, the cruise page can be recalled. Notice that there is no key to select the cruise page. You have to deselect the manually selected page. Recall the ecam cruise page. No, push the flight control key on the ECP. The cruise page is displayed and the ECP has no lights illuminated. Checking all the ecam pages in cruise is normally done by pushing the All key on the ECP. This way of operating should not be associated with abnormal operation. We will now establish a descent for landing at our destination. As part of the approach checks, the status page is checked. Since there is no status reminder on the engine warning display, the status page is normal. The aircraft is lined up on final approach. As the landing gear is extended, the ecam system will automatically display the wheel page. The wheel page is displayed to provide information useful for the landing. For example, brake temperature and spoiler deployment. On passing 1500 feet, with the gear down, a landing memo appears on the engine warning display. Notice that there is a blue action remaining, advising you to arm the spoilers. We will arm them for you.
The blue action line is replaced by a green action completed indication. Notice that there are now no blue action lines outstanding. At approximately 800 feet, the landing inhibit becomes active, and this is indicated by a magenta memo. The landing inhibit message advises you that the vast majority of warnings and cautions have been inhibited during the landing phase. On landing, the chronometer can be stopped to give an indication of flight time. The chronometer only indicates up to 60 minutes and then starts again at 0. There is no indication for the number of hours. When the aircraft is finally parked, the elapsed time can be stopped by moving the selector to Stop. In this example, the block time is 4 hours and 8 minutes. At engine shutdown, the ecam door oxygen page is automatically recalled so that you can check slide disarming. Notice the pulsing status message on the engine warning display. This is telling you that there is a maintenance-related message on the status page that you have not seen. Call the status page. There is a white maintenance status message at the bottom of the status page. This message is an indication for maintenance personnel that a system requires a maintenance procedure at the next programmed servicing. It does not mean that the aircraft is unserviceable. Clear the status page. If the aircraft is being completely shut down, the ecam displays are turned off using the appropriate brightness controls. Normally, DMC-1 supplies the captain's PFD, ND, and the upper ecam screen. DMC-2 supplies the first officer's PFD, ND, and the lower ecam screen. DMC-3 is available as a backup. Let's see what happens if DMC-1 should fail. For this exercise, you are the captain and you are the pilot flying. When DMC-1 fails, the captain's PFD and ND are lost, along with the upper ecam screen. Since you no longer have any information to safely fly the aircraft, you should hand over control to the first officer. You are now the pilot non-flying. Notice that all three displays have a diagonal white line through them. The white lines indicate that the displays are working but are not receiving any data. As soon as the ecam system detects the failure of DMC-1, you will get the standard sequence of alerts. You hear a single chime and see the master caution light. Cancel the master caution. No, to extinguish the master caution light, press the master caution push-button switch. Notice that the engine warning display has automatically transferred to the lower ecam screen and is now receiving information from DMC-2. So that you can carry out the ecam procedure, we will bring up the lower part of the engine warning display and the switching panel for you. The ecam procedure requires you to select Captain on the EIS DMC switch located on the switching panel. Carry out the ecam action. DMC3 will now supply information to the three displays, and the engine warning display is automatically transferred back to the upper ecam display. We can now complete the ecam procedure. After confirmation from the other pilot, the EIS DMC fault message can be cleared. Clear EIS. The line on the engine warning display is cleared, and the status page automatically called. There is a memo to tell you that the configuration of the switching panel is non-standard. Notice the inoperative DMC1 is shown on the status page. After review of the status page by both pilots, the ecam procedure can be completed. Clear status. The cruise page is displayed on the lower ecam screen, and none of the keys on the ECP are illuminated. A boxed status message appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for a DMC1 fault. But if a single display unit fails, there are several ways that the EIS can be reconfigured to ensure that the pilots have all the information that they need. Let's look at several cases of this. If a PFD screen fails, the screen will be blank. There is no white diagonal line, since this is a screen failure, not a loss of data. Because the PFD has priority, the EIS will automatically transfer the PFD to the remaining screen. But if an ND fails, no automatic transfer takes place. If required, the PFD-ND transfer switch can be used to manually transfer navigation information to the remaining screen. Should a failure of the upper ecam display screen occur, an automatic transfer of the engine warning display to the lower ecam screen takes place. Like the PFD, the engine warning display has priority over the system display. System pages can be displayed by using the system keys on the ECP. You have to push and hold a key to temporarily display a system page. While the system page is displayed, a white light illuminates on the key. Note, if a key is held down for more than 30 seconds, the engine warning display screen will be recalled automatically. This happens because the ecam system assigns priority to the engine warning display. As soon as the key is released, the light goes out and the engine warning display reappears on the lower ecam screen. If you need a system screen, you can transfer the system display to one of the ND screens using the ecam ND transfer switch on the switching panel. Click on the ecam ND transfer selector. By selecting the ecam ND transfer selector to first officer, the system display has been transferred to the first officer's FO-ND screen. Notice that the ND is replaced by the system display. It is not transferred. Normal selection of system pages is then available via the ECP. In the unlikely event that both ecam displays fail, The ecam ND transfer selector can be used to display the engine warning display on one of the ND units. Click on the ecam ND transfer selector. As you can see, the first officer now has the engine warning display on his ND screen. If you need to look at a system page, this can be done by pressing and holding the related system page key on the ECP for a maximum of 30 seconds. As soon as the system key is released, the engine warning display returns and the light on the ECP is extinguished. When you are limited to a single ecam screen, the handling of system malfunctions and how you are advised of failures is slightly different. For clarity, we will concentrate on the ecam screen. If an advisory condition arises, the relevant system page is not automatically displayed. Instead, the light on the key for the system and a boxed advisory message on the engine warning display will flash. If an ecam warning or caution is triggered, then there will be no automatic display of the relevant system page. System pages should be called by manual selection on the ECP. To see this more clearly, let's look at a failure. We will only discuss the one ecam screen and the selections on the ECP. You hear a single chime and see the master caution light. Cancel the master caution. When a failure is detected, ecam will give the normal oral and visual indications. On the engine warning display, the failure message will be displayed, and on the ECP, the two clear keys will be illuminated. By looking at the underlined system title, you can see which system page needs to be viewed. In this example, the fuel page key should be selected and held on the ECP. The system page can be studied to provide more information about the failure and then the key released. The engine warning display returns and the ecam actions can be carried out. We will do these actions for you. Now the ecam actions have been completed and only the failure title remains. To confirm what effect the actions have had on the system, reselect the fuel page on the ECP. Call the fuel page. As before, the fuel page is displayed while the key is depressed. You can see on the system page that the cross feed is connected and the pump has shut down. As soon as the key is released, the engine warning display returns. To continue with ecam, a clear key should be pressed to remove the failure message on the engine warning display. Clear fuel. Normally, the status page would be displayed, but with only a single ecam screen available, the status page must be manually selected.
Notice that there is a boxed status symbol on the engine warning display. The status key should be held down and the status page reviewed. The status page can be displayed for up to 3 minutes before an automatic return to the engine warning display occurs. Once the review is complete, the key is released and the engine warning display returns. The ecam procedure is now complete. There are no lights on the ECP. During the approach phase, there is no automatic call of the status page when the flap selector is moved. To remind the pilots to review status, the boxed status symbol on the engine warning display pulses. The status page should be selected as before. In this module, we have looked at various failures associated with the EIS. You will have the opportunity to practice the various failures during the simulator phase. The
Two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings, the SDACs to generate amber cautions.
The FWCs then supply the DMCs for the display of alert messages, the attention getters, and the loudspeakers for oral alerts and synthetic voice messages. To begin, we will look at what happens when one or both FWCs fail. For a single FWC fault, a caution message will be displayed on the engine warning display. Notice that there are no blue action lines, so no crew action is required. No system page is called because there is no system page for EIS. Clear flight warning system. On the status page, you will notice that the aircraft's auto-flight capability is downgraded to Cat 3 single. The inoperative systems are Cat 3 and FWC 1. After a review of the status page by both pilots, the ecam procedure can be completed. Clear status. The cruise page is displayed on the lower ecam screen, and none of the keys on the ECP are illuminated. A boxed status reminder appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for an FWC1 fault. As a result of the failure, if any other warning or caution is generated that would light an indicator, you will notice that only half of the lights are illuminated. In this example, with an FWC1 fault, only the lower part of the captain's indicators and the upper part of the first officer's indicators are illuminated. Note, if FWC2 had failed, the lights would be reversed.
The loss of both FWCs will remove the automatic monitoring of the aircraft systems. A message and information generated by a DMC is displayed at the bottom of the engine warning display. There will be no further ecam cautions or warnings, oral warnings, master caution, or master warning lights. The action lines advise the pilots to monitor the ecam system pages and the overhead panel for local warnings. Notice that there is a Not Avail list on the right-hand side. The Not Avail items are ecam warnings, altitude alerts, the status page, automatic call-outs, memos. The overhead panel should be checked for any local warnings. The system pages can be checked for abnormal indications either by individual selection of the pages or by using the All key to sequence through the pages. We will hold down the All key for you to show you what happens. Note, if the All key is released partway through the sequence, the system stops on the page displayed. To finish this module, we will briefly look at the use of the emergency cancel push button. It is normally used to cancel an intermittent nuisance message. It may be used, if necessary, to cancel most oral warnings. Let's look at an example of an intermittent nuisance message. When an intermittent caution occurs, the normal oral and visual alerts will be triggered. The emergency cancel push button can be used to tell ecam to suppress the caution. As a result of pressing the emergency cancel push button, a white message appears on the engine warning display advising you that the caution has been cancelled. After a short delay, the cancelled caution message automatically disappears and is transferred to the status page. A status reminder appears on the engine warning display informing you that there is something on the status page. Call the status page. The status page is displayed with a white cancelled caution message. After review, the status page can be cleared. Clear the status page. The cruise page returns on the lower ecam display, and there is a status reminder on the engine warning display. For the rest of the flight, you will not be alerted each time the ecam system detects a fault with ILS 1. Now let's see how you can recall the cancelled caution. Press the recall key. If you press and hold the recall key for more than 3 seconds, the suppression function is removed. The original caution will reappear if the fault is detected. You will have the opportunity to practice the use of the emergency cancel push button in the simulator, so we will stop here.
In this module, we have looked at various failures associated with the EIS. You will have the opportunity to practice the various failures during the simulator phase.